Welcome. In today's lecture, we will learn about types of relations. Before learning this, we have to know another concept, which is Cartesian product between a single set. In previous lecture, we were given two sets. We were asked to find the Cartesian product of these two sets. I showed you how to do that. In today's lecture, we will find out the Cartesian product of one set. This is the Cartesian product of A with itself, A cross A. I have written 1, 2, 3, 1, 2, 3, same thing here. In your questions, you will be given a single set and you will be asked to find different types of relation from that single set. Types of relation number 1, reflexive relation. You are given a set. We have to go from a set to a relation. In last video, I showed you the two steps to go from a set to a relation. Step number 1 is find the Cartesian product. A relation is basically selecting sum from all of these ordered pairs. So, selecting a subset from the total set of ordered pairs. So, for this relation R, we have selected 1, 1 and 2, 2. This is known as a reflexive relation because every element of A is related to itself. Every element of A is related to itself. We will see another example. See, I am saying that R is a relation and I have come directly from a set to a relation. I have skipped the middle step of finding the Cartesian product. I am just telling you so that you understand. So 4, 4 and 5, 5. Is this a reflexive relation? See, the condition is that every element will be related to itself. 4 is related to 4. Very good. 5 is related to 5. Very good. But what about 6? Can you see 6 anywhere? No. That means not every element is related to itself. Then it is not a reflexive relation. If we add 6, 6 here, now every element is related to itself. Now it is called a reflexive relation. Now I have added a few more elements. You can see that out of the Cartesian product, I have selected the 4, 4, 5, 5, 6, 6. But I have also selected another few elements. Make the Cartesian product in your copy for your practice. I am not making it because I am practiced. I have done this before. Now, is this still a reflexive relation? Well, let's check the condition. Well, every element is related to itself. But there are also other elements. So what? So what if there are other elements? The condition is that every element should be related to itself. Here it is. Then this is also a reflexive relation. Types of relation. Number 2, symmetric relation. Again, we will be given a set. Everything starts from the set. Now, we are learning about relation. How do we go from a set to a relation? First, we make the Cartesian product. Make the Cartesian product in your copy. I will directly make the relation. You will make the Cartesian product. Look, I have come up with a relation. This relation is a symmetric relation. Why? See, here is 1, 2. Because there is 1, 2, there is also 2, 1. Okay. What about 3, 3? Well, 3, 3's opposite is 3, 3. So it cannot invert. So it doesn't matter. But if there is 1, 2, there should be 2, 1. Let's take another example. Let's take another relation. Is this a symmetric relation? You can easily tell it's not a symmetric relation. Why? there is 2 comma 3, but there is not 3 comma 2. There is 3 comma 1, but there is not 1 comma 3. So if one element is there, its inverse should also be there. Now to make it a symmetric relation, we have added a few elements. Now check, 2 comma 3 is here, its opposite, its inverse is also here. 1 comma 3 is here, its inverse is also here. Now it is a symmetric relation. Number 3, transitive relation. Let's take a set. Now, from set, I have again directly gone to relation, but you know what comes in between? Cartesian product. Make the Cartesian product in your copy. Now, in this relation, I have written 3 elements, 1, 2, 2, 3 and 1, 3, and I am calling this a transitive relation. Why is it a transitive relation? Look very carefully. 1, 2 is here, again 2, 3 is here. That's why 1, 3 is also here. This is the condition for a transitive relation. Let's take another example. Tell me, is this a transitive relation? Let's check. 4, 5 is here. Again 5, 6 is here. So 4, 6 is also here. So far so. 5, 6 is here. 6, 7 is here. Is 5, 7 in the relation? No, therefore it is not transitive relation. It's that simple.